This is the third of 3 tutorials that I'm doing for Java collections. I've done one on array lists, one on sets, and now this one is on maps. I am not going to be showing you the basics of how to use maps. For that, I have a lecture video. I'll try to link it in the upper right here. But assuming that you've watched that lecture and you've done some basic practice at problems, you should now be ready to see this tutorial and really test your skills to see whether you know how to use maps. So this first problem I've got is I call random map. And so this is a way I'm going to be able to generate some random maps. And so the input parameters are a count for the number of items that I want in the map, the maximum key value, it's going to be an integer for a key, an integer for the value, so a maximum value, and then it's going to return a new map with count elements with a key from 1 to max key and a value from 1 to max value. So for example here, if I call it with count 5, it's going to return 5 items. Max key is 10, so I've got 1, 4, 5, 6, 7 is 5 random key values. And then the maximum value is up to 5, so 5, 5, 3, 1, 3 are my values. So I'd like you to stop the video and try to write some pseudocode for this. So you know that you're going to have some sort of loop for count times because you need count number of items. You're going to have to use a random number generator to generate a key between 1 and max key, generate a value between 1 and max value, and then you're going to have to add those items or put them into the map, which you're going to then return. So try writing some pseudocode for this here. Hopefully by now you've tried that, so let's go ahead and take a look at that pseudocode. So we're going to create a return map. And then again, we have to loop for count number of items. We're going to have to create a random number between 1 and max key, create a random number between 1 and max value, and then we're going to put that pair into the map. And lastly, we need to return the map. Now I want you to stop the video again and actually try writing all of that code. Hopefully by now you've done that. So let's go ahead and start writing code. So we create the return map. You have to call hash map or tree map here, and then you can pass it into the abstract class map. So then we're going to have a loop from 0 up through count -1. And then to create a random number, we can use a couple of different things, but the easiest one, the most compact one, is to use math.random. This will return a random double between 0 and 1. And then by multiplying it by a value like max key, this will now generate a double between 0 and max key -1. But we need 1 to max key. So what we need to do is we'll convert that to an int, and then we'll just add 1. So that'll create our key, and same thing, we'll do the value, and then result.put will add a key value. And you notice how nice it is that if you use the variable names like key and value, it just works perfectly. So we're going to put that pair into the map, and then lastly we need to actually return the result. Let's try running this and see what happens. Okay, so we've got a random map. This was supposed to generate 5 items here, and it only generated 4. Do you notice that? So the reason why it only generated 4 is because 2 of them collided. So we actually need to add a couple of lines of code here. So this is the line that generates the key, and we really want a unique random key. So you could do a couple different ways, but I thought the easiest way is to simply make sure that it's unique by writing a little while loop. So while the result contains key, just create a different key. So now when I do that, I should get, these are 5 independent things there and 5 independent things there. So now it's creating all 5. So that's how to generate a random map. The next function I'm going to show you is, I call it build histogram. A histogram is, it's kind of like it's basically like a chart where we have buckets for each frequency of a value. So here's an array list input, and we want to see how many ones there are. Oh, there's one here, and there's another one here, so there's two. How many twos are there? Well, there's 1, 2, 3, 4, 5, 6, and so on. So there's 4 3s, 1 4, 2 5s, and 1 45. So I'd like you to write some pseudocode first for this. And basically, you're going to have to look through this array list. For each element in there, you're going to have to stick it into a map. You're going to create a new return map. And every time that you get a value, you're going to stick it into the map, not the value itself, but you're going to use the value as the key. And the value is going to be how many times that value exists. So you're going to stick it in first as 1, and then every time you find it again, you'll increment that 1 to be 2, and then when you find it again, you'll increment it to 3. So it'll generate this type of output map. So I want you to write the pseudocode for that. Hopefully you've done that, so let's take a look at what that is. So of course we need to look, we have a return map that we're going to need to return. We're going to loop through that array list input, and there are a couple different ways to do this. You could either get the, well, the way I did it is if the value is in the map, then we're going to get it and then add 1 and set it. Otherwise, we can just set the count to 1. Another way to do it would be you could have an integer variable for the count, and you can try to get it. Otherwise, the count is 0, and then you can so if it's 0 if it existed, otherwise it's whatever it was, and then you add 1 to that, and then you always set it. All right, so I want you to try to write the code on your own as well. Hopefully by now you've done that. So let's take a look at, oh, of course we have to return the map. So we're going to need to build a return map, and so again it's going to be a hash map up front and then a map in back. So here we can now use a for each loop, because we are not going to be affecting this input array. So it'll give us each key one at a time. And now we can use the contains key function of maps. So if the result already contains that key, then we want to get the value of that key, add 1, and then put it under that key. Otherwise, we know that it doesn't exist, so we can just put it as value 1 and then return the map. So when we run that, so here's that input, and then it comes out with these same outputs that we're looking for. The next function I've got for you I call remove set. So we've got a map as an input, for example here, and I'm going to give you a set of items that I want you to remove, which may or may not exist in the input. So here, I want to remove 2, so it's going to take these out, and I want to remove 3, so it's going to take these out, and what we should be left with is just this first item, and then these 3 items, and sure enough, that works. So the overall algorithm is you can look for each of the removes, and you can check to see if it's in the input, and if it is, you want to remove that. Or you could do it the other way. You can take a look at each of the inputs. You're going to have to use the key set and then check to see whether that key in the key set exists here, and if so, you can remove it. But that's going to be a little bit more challenging because you do need an iterator. So I want you to try writing some code. I would suggest going with the removes, looking through the removes first, and then checking to see whether each remove is contained in the input. If so, you want to remove it. So hopefully you've already written that pseudocode, so let's take a look at what that should look like. So again, we cannot do a for each over the input, for each loop, because the input is going to be removed, and that would throw a concurrent exception. And we can't do a simple loop because we have to iterate the key set. So, and there's no indexed get. Okay, so actually what I'm going to do is I'm going to try iterating the input key set. So that's the alternative. And if the input key is in the removes, I'm going to remove it from the map. So hopefully you've tried writing the code, so let's go ahead and take a look at that. So I'm going to take a look at the input key sets iterator, and we're going to do a while loop. And I want to find out what the key is for each item, and I can use contains on the removes set to see whether it's contained by that. If you do it the other way around, not only can you use a for each loop on the input, but you can also use contains key, so you don't even need to extract the key set. Okay, but if the removes does contain the key input, then you have to use the iterator to remove that key. Okay, so let's try running this. Okay, so we are using the output from that last result, and we're going to try removing these keys 2 and 3. So 1 remains, 2 gets removed, 3 gets removed. We're left with the 4, 5, and the 45. So that seems to work. Now, those of you who paid attention in the book about key sets and set operations may realize that there's a faster way to do this. We are actually doing a remove all. We take the input and then we remove all the things from this set. So we can actually, I can just take all these lines here, comment them out, and do a input dot remove all. Actually, we have to get the key set. Input dot key set dot remove all, and then pass in the removes. Let's try running that. And you see it does the exact same thing. We might as well go ahead and try writing it the other way. So we can do a for each loop. I'm going to look at each int remove in removes. Actually, call it a key. Make it nicer. So for each key in removes, if the input dot contains key of that key, see how nice it is? The key just popped in. If it does contain that key, all I have to do is to remove it. So I do an input dot remove of key. And let's try running that. And you see it does the exact same thing. So so 1 line is best. Then it went to 3 lines. This is 1, 2, 3, 4, 5. So it's either your choice of 1 line, 3 line, or 5 lines. So you've got quite a few options there. Thinking about which one to do when you have multiple items is sometimes very useful, because if you can use a for each loop, it's going to be faster. It's going to be less code. I have one last function that I want to show you. I call this one remove all, and of course I just used remove all on sets, but there is no remove all on maps. But wouldn't it be nice if there was? So the way this works is you have an input map. I've got a removes map that I'm going to remove every key from the input which exists in the remove. So key is 1 here. So there's no 1. It's not going to do anything. Key is 3. Here's a key 3. Doesn't matter what the values are, even though the values don't match. It's going to remove that 3. And then key 6, it's not there, so it's not going to do anything. Key 8, not going to do anything. Key 9, okay, it found a match with this key 9 here. So the 3 and the 9 get removed. So we're left with the 2, the 7, and the 10. And I want to return, this doesn't normally happen with remove all, but I always think this is what it should do. It'll return a new map with the items that you returned. So the overall, I want you to write the pseudocode for this. So the overall algorithm is you've got these 2 things you're going to look at. And just like in our last problem, I want you to think about which way you want to do it. You can either look over the input, and then for each of the input, you can look in the removes. Or you can look over the removes, loop over the removes, and for each of those, look to see whether it's in the input. Now think about which which of these arrays or maps gets modified. So we are going to modify the input. We're not going to modify the return removes. So think about which is the most efficient to do. So either way, you're going to check to see if one is contained in the other. If it is, you want to remove it from the map, and you want to add it to this return map. And you probably want to add it before you remove it, so that you can look it up. So try writing that pseudocode. So I'm assuming by now that you have tried. So let's go ahead and show you what that looks like. So we're going to start by creating a map to return. So we can't do for each over the input due to the removes. And you can't do a simple loop because you've got key sets. So in this case, I should have chosen the other way, but I'm going to iterate the input key set. And if the input key is in the removes, then I'm going to add it to the new map and remove it from the old map. And last thing is I'm going to return it. Now, if I had been a little bit smarter, I suppose, what I should have done is I probably should have iterated the removes. And then if the removes, if that key is contained in the key set contains key of the input, then I can do it. It'll avoid the iteration code, and it'll save a few lines. Now, I'm not actually going to show you what the code is. I want you to go and try this code on your own and see if you can make that work. With the code that we wrote earlier to have the random maps, now you've got a couple of functions to function to create a couple of random maps for you. So isn't that nice? So try running that and see if you can make that work. If so, you pass the exam. You are now the king of maps. So again, what did we learn in this maps tutorial? So complicated things are when you're dealing with maps, you want to think about when you have multiple maps or sets to deal with, you want to think about which is the outer loop and which is the inner loop. You have contains key, which is a great way of looking things up in a map. You don't actually, otherwise you have to go into the key set. Another basic thing is that you can't just do a for each loop on a map. You need to get the key set, and then you have to iterate that key set. So that makes it doubly important to try to figure out, can you use a for each loop on one of these? Adding to maps is pretty straightforward. We didn't show an example of it here, but same as with sets. If a map already has a key value and you try to stick it in there, it's not going to create a second item. It's going to overwrite whatever the first item is. So that's another thing for maps. So I hope you found this useful. Please like and subscribe. That helps other students find these videos. So again, this is the third of 3 tutorial videos on array lists, sets, and maps. So I will try to put some links for those up here in the upper right as well. And that concludes the Java Collections tutorials.